Okay, so now I want to start talking about naming. So we're going to talk about naming compounds. And we are going to start off by naming binary compounds. Now, binary, from the word, you can kind of tell that this is going to mean we have two types of atoms, okay, in this molecule. Right now, we're going to talk about nonmetals only. Because that's what most binary compounds are. Most binary compounds are binary molecules, meaning that they're non-metals, molecularly bonded, but binary can refer to ionically bonded compounds as well, but we'll get to that in just a bit. So, an example of a binary compound that I gave a little before is HCl, right? We have two different elements in here, and now we're going to start to name it. So the method to name it is you're going to first name the element that comes first in the formula, alright? And then you go to the second one. Pretty simple, right? First, second. So first we have hydrogen. Okay? Our second is chlorine. Now, the way to name it is that the second element becomes an ide. The ending of this name becomes ide. So chlorine becomes chloride. So the final name for this compound right here is hydrogen chloride. That's probably something you knew already, but now you know why it's called this way, because this is the method to name binary compounds. Let's do another one. Let's say we have SiC, okay? So that's our compound. So our first element here is, if you look at the periodic table, is silicon. And our second element right here is a carbon, right? I'm going to write it up here so we can see what we have to do with the endings. We have carbon, and it's going to change to an ide, so this can become carbide. So silicon carbide is the molecular formula for this. If you want to just do one more, let's say we have HI. First element is an H, we have hydrogen. Last element is an I, so we have iodine right here, right? And this becomes iodide. So I'll put that right there. My final name is hydrogen iodide. So the next thing I want to talk about is the fact that sometimes you can have two different elements that combine in different ratios to still give you a binary compound, but you're going to have a prefix added to it. Okay, so the thing to remember is when I say binary compound, it means two different types of elements, not two atoms. Alright, this means two different types of elements are included in your compound. We're not limiting it to just two atoms of elements. What I mean by that is as follows. Let's take the example of CO2. Now, these are both binary compounds because they are only made up of two different types of elements, C's and O, right? We have C and O. Now, if we use the method of naming that we just used, we would say, well, in both cases, my first element is carbon, right? Carbon, carbon. And in both cases, my last element is oxygen. So we're going to change oxygen into an ide, becomes oxide. right? Now this is confusing because these are not the same compounds. So what do? We use prefixes. So we're going to use Greek prefixes to fix this problem. Greek prefixes are as follows. So what we're going to have is the prefix. I'm going to put the prefix here, and I'm going to put the meaning, or what number it's relating to. So obviously the number it's going to go from. So obviously the number is going to go from 1, and they're just going to go up. We can take it as far as, let's go as far as 10. Because that's, alright, so 1 to 10. These prefixes are important, by the way, so good thing to memorize them. So we have 1 through 10 right here, and so for 1, we have mono. 2, you probably know, is di. 3 is tri. 4 is tetra, like tetravalent we learned earlier. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 nona. And 10 is deca. Right? So let's use this to kind of go back and name these two compounds. In this case, we had the 1 carbon and we have the 1 oxygen, right? So what you do is you omit the prefix for the first element. I'm going to write that right here. So what you do is omit prefix for first element, and then you put into the second one. Okay? So in this case, we're still going to have carbon right there. We have carbon right there, right? So now for our second element over here, you just have monoxide, right? Because we have 1 oxygen, 1 is mono. So we have carbon monoxide. Pretty common gas, I'm sure you guys have all heard of. So in the second case, we have 2 oxygens, 2 is di, carbon dioxide. Okay? So I hope that kind of clarifies what I mean by the difference between a binary compound being 2 types of elements, not necessarily only 2 atoms. Because you can clearly see that in this case, we have 2 atoms. We have a carbon atom and an oxygen atom. But in this case, we have a carbon atom and 2 oxygen atoms. Okay? So let's try naming a couple more compounds using what we just learned right there. So let's say I have SO2 and SO3. Okay? So using what we just learned, we're going to take our first element, which in both cases is sulfur, right? Both cases is sulfur, and you omit the prefix for the first element, so we have omitted the prefix. Now for the second element, you're going to go in and look at prefixes. So for the second element over here, we have 2. We know from earlier that the prefix for 2 is di, so we have sulfur dioxide. And then in here, we have 3 oxygens, and we know the prefix for 3 is tri, so we have sulfur trioxide. Okay? So I'm sure you guys have noticed so far that in both of these examples, we've only dealt with compounds in which the first element is mono. It's 1. So over here we have 1 carbon in both, we have 1 sulfur in both. Now, what happens if we have a compound where the first element exists in more than 1? So over here, I'm going to extend this kind of mantra right here. So it says omit prefix for first element. Now I'm going to extend it to only for mono. So what that means is you're going to omit the prefix if your first element exists in ones. Okay? So this is what I'm going to do. I'm going to do an example right up here, right next to this chart so you can kind of see it. Let's say I have N2O5. Okay? What we're going to do is this. Now we have the first element as nitrogen, right? Second element is oxygen. I'm going to write that as oxide. So that's our first step, right? Write the basic name, we're going to go back and do the prefixes now. So omit the prefix of the first element only for mono. Now in this case, this is not a mono, right? We have right here 2 nitrogens. So that means we have a dinitrogen situation. So I'm going to go back and write dinitrogen, right? And in this case we have 5 oxygens, 5 first to penta. So we have right there. Now we got 2 vowels right next to each other, so we're going to clean this up a little bit and write dinitrogen pentoxide. Okay? So I hope that wasn't confusing when I said omit the prefix the first time. I just wanted to build up on it. The problems that you might encounter in an exam, I'm just going to do a couple problems now, would be as follows. They'll give you a binary compound. And they'll tell you to find it or write its chemical formula. So first example I'm going to do is sulfur. Let's do sulfur tetrafluoride. Okay? So we have sulfur tetrafluoride. So we know that when we go backwards, when we're actually writing the name for the compound, we start by naming the first element by its name, right? So we have here sulfur is its first, so we're going to just write the chemical formula for sulfur. There we go. And in terms of the second element you take your second element, you turn it into an ide. So in this case my ide is a fluoride, so my second element is an F. Then you go back, see if there's any prefixes. In here I have no prefix, so I have a mono sulfur. And over here I have tetra, which means, from up here we know tetra means 4. So that means I have 4 fluorines. So SF4 is sulfur tetrafluoride. Let's do one more. Let's do this is tetraphosphorus decasulfide. Okay? This looks pretty hairy, right? So let's do the same thing we did with the other one. So once again we know that when we're naming, the first element named is the first element in the binary compound. So our first element right here is phosphorus, which is P, and our ide element, which is our second element, is sulfide, which is S, right? So now we're going to go back and see if we have any prefixes. For the phosphorus, I have a tetra, and I can just remember that tetra means 4, so we have 4 phosphoruses. And over here we have deca, which is, according to this list, deca is 10. We have 10. So we have P, 4, S, 10 is tetraphosphorus decasulfide.